All right, welcome everybody to the Cold Truth podcast where the addiction is chemical. I am joined by my co-host Eli. Eli, how are you doing?
I'm doing real good, Mike. I cannot believe you came up with that tagline in about a split second. That's unreal.
That's what I'm known for around here. I try to keep it crafty. So
That's right.
cool. Well, today we got a really special guest. This is the first episode of the Cold Truth podcast, and we hope that this will be a great resource for you guys just to learn, hear from people in the community, and just have a good time. So, Eli, would you like to introduce our guest today?
I sure would. Yeah, Ryan Reardon. Man, I feel like we go way back, and Ryan was, I think, my first guy in the industry that it was like, wow, here's a guy who really is a great engineer, and it wasn't just me saying that, but his customers were saying that, and so I think we go back to the production winery days. Maybe I won't say the name of the company, but had a lot of good times there. So Ryan, thanks for joining us today.
Yeah, no, thanks guys, and always appreciate it. Honored to be on here for sure. And all of you guys, including the customers, are far too nice. It at least puts hope back in humanity that people still say nice things about you. But yeah, we do have some time together, Eli. We've always stayed in touch, and yeah, I mean we did a lot of work back in the day together for sure, and still looking to do more now. It hasn't stopped yet.
Yeah, yeah, amen. Well, very cool, Ryan. Just to kind of introduce you to our listeners, I've kind of seen you at two companies, but I don't want to steal your thunder. So why don't you just go ahead and kind of walk us through your career?
Yeah, no, totally. I'm Ryan Reardon, out here stationed on the West Coast in Lodi, California. I am by degree a mathematics minor and a major in mechanical engineering. That was always a joke from my high school math teacher. I had to drop that one in there. Um, Honestly, I've been in this industry for 10 years, which is a lot of time for me. It's not a lot of time for the overall industry. We literally see, a lot of people have 20, 30, 40 years of time. But I've been in it for 10 years in industrial refrigeration the entire time. The majority of that experience was in large industrial ammonia systems, and over time picked up, transcritical CO2 and some synthetic refrigerant systems. I had zero knowledge of this industry going into college. I had no desire or understanding of it. I wanted to do automotive design, and through college and through my girlfriend at the time, who is now my wife, um, she had her brother or stepbrother worked in the industry, and they were looking for somebody. And I said, hey, here's my resume as I was getting ready to graduate, thinking nothing's going to come of this. He worked for a design build contractor on the West Coast out here, and ended up interviewing with them a few times, and I guess they liked me enough to bring me on board. Did just short of 7 years there, doing kind of everything. Started out as a project coordinator, kind of picking up all the loose ends on projects, making sure things were ordered, making sure the as-built drawings were done, and got into project management and into engineering, and eventually into sales. Upon my departure from there, uh, did not I left there without a plan, and that is something that I'm not sure too many people understand. It Looking from the outside, it looks like there was absolutely a plan, but I can tell you with full confidence there was not one. It was we were going to figure something out. What I told everybody at the time, and I was actually somewhat serious about it, was, hey, I might look into doing coaching for trap shooting. That's one of the hobbies of mine. We don't have a lot of coaching out here on the West Coast, and it was something I was interested in. So, um,
I didn't know that. That's cool.
yeah, we travel around a little bit for the.
I'd love to go shooting with you sometime. I haven't done it a ton, but it's super fun. And
Next time you're out here, we'll make sure it happens. But in saying that and taking my last month at that previous contractor, taking my project manager around and passing off the torch to him and the customers I worked with, and saying, hey, you used to call me, you're already calling this guy anyways. Give him a call, and that was Randy Crooker, absolutely great guy. Um, Still friends with him, but in seeing that, I saw a lot of, hey, where are you going? what are you going to do? What do you mean you're leaving? Sort of situation. And I saw this opportunity for consulting and to support the overall industry as a whole, especially here locally. And that's what really launched and gave birth to R2 Mechanical Consultants. And so it's just myself for the time being, but we do consulting, design, anything for any sort of refrigeration system, whether that's ammonia, CO2, or any synthetic refrigerants. It could be chiller systems, primarily for the food and beverage industry, but we can support other chemical industries as well and other processes. And we're really here. The big push was to be able to support everybody. It's not just me working with one contractor, one company. I'm here to support the end user, here to support the contractors, and even the manufacturers as well. So, if there's ideas people want to run past me or want to develop a project, or if contractor needs support for a project they already have, they need drafting support or engineering support, we're here for you on that one. So that is the short story on me.
Well, I love it, and just where you ended there, Ryan, I think we at Macha BSM we like being in the same spot where we kind of avoid that conflict of interest, where you're able to come and support both the customer, the contractor, and step in wherever needed. And your support, I just think back to this production winery we worked at together that was, well over 100,000 pounds of ammonia. And I remember the first time I saw one of your reports, I remember thinking, I don't know exactly what this is, but I was looking through the recommendations and going, this is amazing. Where you were like, hey, you don't need this compressor or whatever, you can get rid of that. You can consolidate these two systems or whatever. Just a really high level, it didn't fall into, it wasn't exactly a mechanical integrity audit. It wasn't exactly, a compliance audit. It was like its own engineering review that I remember the customer just going, this is amazing. And now we can build out our 5-year kind of CapEx project list or whatever. And anyway, so I just like the way you tend to look at those systems. Anyway.
Yeah, I was just met with a new engineer to the overall industry yesterday, and kind of talking about this. And there is so much to the technical side of our industry, to the engineering side, the actual numbers, the ones and zeros that go into it, and we can study exactly what that molecule of refrigerant's doing in the system and really nerd out on that whole thing. But at the end of the day, this is going in somewhere that's real, and for a company that is going to rely on this for their production needs, for their business. And so there has to be a practical aspect to it. And we were just talking about that same facility the other day. It was actually, their system was close to 250,000 pounds of ammonia, 250,000 pounds of ammonia. The number that always stuck with me is they had over 5 miles of refrigeration piping in their facility. That excludes the relief piping, which was also quite expensive as well. But that's a lot of work, and to take that and say, hey, we don't need to make this perfect. We need to make this into something that's going to work for you, be safe for your facility, and something that's going to support your needs moving forward and plan for the future, that facility in particular. And we see this across the board of almost any refrigeration facility and any business that grows. There's a lot of times not a lot of thought into that growth. We start adding on to, we need a pipe here and a system there and a chiller here, and that thought wasn't there. Correct.
Mm-hmm. You just end up with this sprawl, and it's this disorganized system, and it's like, why is this recirculator in this random room? And yeah.
Yeah, so we tried to take a practical approach for that customer and for all of them, in fact, um, as far as what can be done to make this reliable and economical and work for your facility.
Man, that's awesome. Hey, Eli, who the heck are you?
Yeah, that's a decent question. So I come from around Ryan's neck of the woods, so the Central Valley of California, so near Fresno. Grew up in a small town called Reedley, and more recently was in Kingsburg. And man, I've been in the industry for about the same time as Ryan, and was with another PSM consulting firm there in Kingsburg, California, and that's kind of how I was interfacing with Ryan. a couple years ago, moved out here to Alabama, northern Alabama, city called Huntsville, which is the Roll Tide. Yeah, that's right. So,
I have to put that out there. I mean, if you don't support some team, it's either War Eagle, it's Roll Tide, and if you're weird, it's Go Vols. And I have to put that out there. So continue. Go
I don't think if you don't, I think you get kicked out of the state for sure.
ahead. No, it's a religious experience, and yeah, you have to affiliate with something. And if you say I don't, I'm not a fan, it's like you're not welcome here. So you can go away.
I'm fairly busy these days, and so I don't always track the scores of these games. But we have a gentleman who comes into our office and cleans, and his name is Sledge, and he's a humongous Bama fan, and so he wears the all the accoutrements and everything with Bama, and so I can always just tell by his countenance on Monday, how the game went on Saturday, and so but now every time I see him, I'm just like Roll Tide. He's like Roll Tide, like he's on it, and so.
It's the equivalent of like saying God be with you. Like it's that to that level. Anyways, you came to Huntsville, and then what happened?
Yeah, so I came to Huntsville and started my own PSM firm here, and trying to kind of build a book of business, and it's going decently well. And so we've like more recently, Micah, where you're at, where we've started a Pacific Northwest branch in Idaho, in Moscow, Idaho. But we're kind of a full service PSM firm, which is what I was doing at my previous company, and yeah, it's kind of growing. And Micah, you want to kind of share your participation in that?
Yeah, yeah. Me and Eli kind of go back to the beginning on this endeavor. I was, just a young guy, and we went to the same church, and I think he caught me saying I was interested in getting into sales and business development, and at the time it was just him, and he was, and time came right, gave me a call. I was like, hey man, you want a job? And I had no idea what ammonia was. I had some background in HVAC. I was a assistant technician for a while, but I couldn't tell you what ammonia was if I smelled it. And so but I was excited to learn, and so I was working out of Eli's upstairs like playroom at his house, and I have we're cranking out reports, and it was fantastic. And it's since then I think we've grown to, like, man, we're coming up on 20 people. We're at, I think, like 15, 17 or something like that. And so yeah, I've been mostly on the business development, some management, and then I've also done a lot of consulting as well. So I've been going out and completing mechanical integrity audits and that sort of thing. And so I try to do the best I can. So it's a fast-paced team over here. We love it. But that's and then yeah, we're out in Moscow, Idaho. So we have our office out here. It's just 3 of us, and we're looking to expand. Ryan, you would know how much work there is in the Pacific Northwest and down the West Coast. It's too much. So much. Yeah, it's insane. So
You guys got a lot of potatoes to process out there in Idaho as well. So, but what I got to say is, it's Eli, and correct me if I'm wrong. You guys been going at this for 3 years, roughly now, and it has been very cool to get to watch, from a distance, as far as you guys growing and building and expanding, and now um, following the Rita show, which I was not at, but I heard a lot about, and I think you guys are definitely making a big impression on the industry, especially for the entire rest of the country. I always tell people I have a very narrow view. I'm focused on refrigeration and really focused on the West Coast primarily. And so I don't necessarily see or am tuned into the rest of what's going on in the country. But you guys, I think, are making a pretty big splash out there.
yeah, it's just the mustache. It's just Eli's mustache. Everyone remembers it.
So I like having a mustache. I've had a mustache a long time, but now I'm like locked into it. So this podcast image is going to have my mustache on it, and so yeah, I'm stuck now. So
What would happen if Theo Von shaved the mullet? Like
I, that's right. That's the equivalent. My daughter literally says, "If you shave your mustache, you won't be my daddy anymore." So, I'm like, all right. So, oh man. Well, Ryan, one thing I see that you're doing, I think I saw something on LinkedIn with you. Did you partner with the VAPCO on some kind of low charge talk, or what happened with the low charge kind of innovation there?
Yeah, wasn't I, definitely a partnership. Working with Kurt Liebendorfer over there at VAP Cold, absolutely amazing guy and an absolutely amazing team. We did a white paper, which I believe they have published or are going to publish. I've seen some top secret versions of that, but it was not necessarily any design work per se for a low charge system. Evapco has their Evap Cold systems that they've created, their penthouse units, their chiller units, and other Versa split systems. But what we actually set out to do was to compare, which we don't get a good opportunity to do so, but to compare truly apples to apples of a low charge, packaged ammonia system versus a transcritical CO2 system and a field erected ammonia system for the same facility. And so we took a project that was a potential. It ended up not happening, but we took that facility and designed it completely 3 times over, one for each design. And in doing so, compared, hey, what are some of the challenges going to be from the installation? With a field erected ammonia system, you're going to need a machine room, but you don't necessarily need that with the transcritical CO2 or the evap cold or low charge packaged ammonia design.
Are those both just skids, Ryan, that kind of sit outside the building? Is that why you don't need the machinery room?
Yeah, they're going to have their own enclosure. The CO2 system is going to be more of a rack that if you're used to the supermarket realm of things, it's a big box, that's got panels on it and a bunch of compressors and stuff inside there. And the evap cold units are more of for the most part, depending on their size, some of them have their own little mechanical room or machine room, built into it. You could walk into it. It's got ventilation on it, compressor vessels, everything, controls, and all that. So they're fully enclosed, fully insulated, and everything. And with that study, we went on to look at, hey, what's going to be the energy usage? What's going to be the water usage, the wastewater usage? What are going to be some of maybe the compliance costs or aspects you need to take on of that? And we got the opportunity to kind of present that at the SIBA conference in 2024. And this past year in 2025, we got to present it again at the IIAR conference as well. So that very exciting. Yeah, that was I got to say, that was an amazing experience for me, very humbling. I think from an engineering standpoint, I have to say the IIR show or conference is one of my favorite. And starting out and going there, you see, all these great guys or people just presenting, all very influential people, your Bruce Nelsons, Doug Reindells, Todd Jekyll's, all these people. And to get to be one of those presenters was very exciting and awesome to me. And to be able to present to a room with a lot of my peers and also some of the guys I look up to. Pat Cocaine was in there from APCO and Mike Davidson from CE Sales and Adam Thomas and Rob Perkins from LA Roser. Guys that I've worked with or guys that I look up to this day were in there, and that was super exciting.
Well, I gotta say, you talking about presenting makes me reminds me of another time I saw you in action. Was at you were leading a PSSR meeting, a pre-startup safety review meeting, and it was like going into the Fourth of July holiday, and I totally was thrown off guard because you threw up there like this big old American eagle with like the red, white, and blue that looked super cool, and all us like the blue collar guys were all just like, oh, that's cool. Like, what is this about? And so we yeah. Yeah, that's right. Got to know your crowd. So I guess maybe we don't do that for the IAR engineers, but yeah. Anyway, well, that's awesome, Ryan. It might be top secret, but can you kind of give us like a 60-second version of what the findings were on the three different systems, or what are the kind of high level results there?
Totally. And I think the presentation was published not necessarily the white paper, but the presentation was published through IAR with the conference. But in short, we found that the low charge ammonia system was going to be the most expensive initial cost, but it also ended up being the most energy efficient because those individual systems can shut off. Their design with adiabatic condensers allows them to use much less water throughout the year, and even more so, they end up being over surface area for low ambient conditions because of how big those adiabatic condensers end up being. So they use far less energy, much more efficient. The transcritical system was, I believe, the cheapest to install, but it had the highest energy usage, if I'm not mistaken.
Don't they run like super crazy pressures?
It's relatively crazy. I think for other industries, it's not. Transcritical CO2 is going to run potentially, 10x of what an ammonia system is going to run at. So if we're running 165, and this part isn't, the math isn't totally accurate here, but if we're running 165 psi G on an ammonia system, the transcritical system could be running at 1200 or 1300 psi on the high side. But flip side to that is the ammonia system at negative 40 is going to run at whatever that is, 9 inches of vacuum, and the CO2 system is going to be about 150 psi, give or take. So it's still positive pressure. So it has its pros and cons to it for sure. But yeah, that was the report. There was the buildings needed to be structurally modified to support the package designs, whether that was transcritical CO2 or low charge ammonia. Like I said earlier, you would need a machine room for the field erected ammonia design, and that design as well used evaporative condensers, so that used a huge amount of water compared to the other two designs. Yeah, so there's a lot of pros and cons, and we even took the utility costs and punched them out to potentially 30 years and added in 5% inflation, if you will, over time. And that's where we started seeing differences of, hey, yeah, the transcritical CO2 system is cheaper by millions of dollars up front, but over time it's going to cost you more. Build a new building owner that's going to own this building for 30, 40, 50 plus years potentially is going to actually end up paying more at the end for this cheaper system.
Oh, got it. And when we say low charge ammonia system, what is that category in terms of like how much ammonia is in one of those systems?
The kind of rule of thumb, I think, is under 500 pounds. For us on the West Coast, that gets us into CalARP Program 1, if you will, which has got the least amount of compliance items you need to take care of. For the rest of the country that doesn't have CalARP, of course, that you're well outside of RMP and the 10,000 pound threshold. But I do see some systems, depending on the design, are going to be potentially 700 pounds, 800 pounds, but they are relatively very low charge for what they do, where you don't have a large central high pressure receiver. The charge in an off state is going to end up probably in the suction accumulator or surge drum or whatever that system's utilizing on the low side rather than being stored on the high side.
Right. Well, one thing I learned was when I had some out of state clients when I was in California, but when I moved out of state and all of my clients were outside of California, my eyes were open to it's a totally different world, and the regulatory environment in California is just way more intense than anywhere else. And so what probably anyone outside of California doesn't recognize is that if you're in California, if your quantity of ammonia is between 500 and 10,000 pounds, you're subject to their CalARP program level 2 typically. And depending on the county or CUPA who's enforcing your program, they'll actually have like an annual inspection where they're coming out and inspecting your whole program. And when I talk to a facility in Alabama, and say, hey, when was your last inspection? And they're like, are you talking about a fire inspection? What are you talking about? Because there's no regular inspections, so they're just waiting for the EPA inspection or OSHA inspection. But as you can imagine, probably some people here are like, why do you care to have a low charge ammonia system? But in a state like California, that's a huge advantage if you're not getting on the radar of these Koopas who are doing those inspections.
Absolutely. It definitely can be. And there's other advantages as well, beyond just the compliance side of things. Depending on the location of the facility, if there's a, nearby neighborhood or, school or, more businesses, commercial businesses, retail businesses, things like that, it may be great to have a low charge system to where your potential offsite consequences are really minimized. And that's actually something else we looked at with the study as well, was, hey, what's the offsite consequence of this huge field erected ammonia system versus the low charge system? The field erected system had an offsite consequence extending miles or a mile and a half or whatever, and the low charge system was whatever it was, 300 yards, 400 yards, something like that. And the transcritical system, which we don't necessarily look at for CO2, what the offsite consequence is, but CO2 is, an asphyxiant. So that would actually be localized if the charge was lost potentially inside the building. A large, CO2 charge being lost inside the building could, potentially overcome people as well. So those were things we looked at as well. But that's a good advantage of a low charge ammonia system, is minimizing that offsite consequence.
Right. Well, Ryan, what else is going on in California? I miss my old home, and what's going on out there? What trends are you seeing? What are your customers asking for help with?
Yeah, well, we've got a horrible weather trend right now. It is like 48 degrees and gray and cloudy, which fits great for the Pacific Northwest. But for this California guy over here, I miss summer already, and we've just started winter. We're very close to that. But I digress. Anyways, from California, I think our industry right now is very skeptical of what's going on. We're seeing, from the contractor standpoint, we're seeing end users have a lot of quoting activity and looking to do a lot of projects, but those projects aren't getting awarded, or they almost are and they're getting pulled back. Probably has to do a lot with the economic situation for the country, and a lot of people are speculating on potential Fed rate cuts potentially coming up this December. Maybe businesses are waiting on those interest rates to come down a little bit potentially. The California Air Resource Board, and this isn't new news, they had their final ruling that kind of came into effect in the last couple of years that really started pushing refrigeration systems away from synthetic refrigerants, or using ones that have much lower GWP values. For example, if you're to build a brand new refrigeration facility today, or a facility with refrigeration, you cannot use, for the most part, a refrigerant with a GWP greater than 150. Now, that's not true across the entire board, but if you're going to do a large built-up system, the GWP of that refrigerant cannot exceed 150, which cuts out a huge amount of the refrigerants that we use. Of course, R22 is out the door. R507 is out the door as well. But that 150 number even cuts out current favorites like R448A, and gets us into the HFOs and the A2L type refrigerants of R454C and whatever it is, 513 and 1234ZE, and whatever flavor you want there. So we're seeing a lot more CO2 activity or interest out here on the West Coast.
Yeah, they just keep. Well, I find that they keep tightening up, and then the rest of the country kind of follows suit. Unfortunately.
Yeah, and I think the rest of the country is going to get even tighter than California. So I have to say, I'm going to give one to the federal government and the EPA here with their AIM Act that we've talked about a lot, I think, as an industry as a whole. Uh, their most current, or the final ruling on their technology transition stuff for the AIM Act uh, follows a lot of what California has already done. Like you're saying, Eli, the rest of the country kind of follows, usually, or maybe follows suit, or some states will follow suit of what California does. But they literally took what CARB did and copied it, adjusted some of those limits to be even tighter, but then they changed the rules by one line to say that if you're going to increase capacity of a system, you also have to fall underneath the AIM Act and these lower restrictions as well. California kind of had some gray areas because it only applied to new facilities, facilities without refrigeration, and equipment replacement of 75% of evaporators and 100% of compressors and condensers. So that and was a big piece, but we never talked about anything about capacity increase. But now, if you have a facility that in Alabama potentially, and this is coming in first of this coming year, hey, we have a R448A system, synthetic refrigerant system, and we want to add on another room, and we want to add on X amount of tons of capacity. That is going to get that facility into the AIM Act, and the restrictions on being able to do that, they'll have to change to a lower GWP refrigerant.
Wow. Yeah, that's what's funny too is it creates this black market of like these old freon gases, like because you're not even allowed to buy them, and so I've seen news stories of like people smuggling gas over from Mexico, and it's like this. Yeah. Anyway.
Yeah, these from my read through of these codes, it doesn't affect retrofits. And again, we're talking about non-synthetic refrigerants here, or sorry, we're talking about synthetic refrigerants, not natural refrigerants. But it doesn't affect retrofits. You could still go put R448A in the system as of next year. But if you fall into any of the regulations or rules of, hey, we're adding capacity or we are replacing all this equipment, that's where it comes into play there.
Something I'm curious about, sort of related to that, is related to the government shutdowns. How did that affect California, and then bouncing back? Like you're saying you're seeing the EPA, or those regulations starting to tighten up, and they're probably going to tighten up across the country. Does that have anything to do with government shutdowns, or did that have any effect on California?
I, I don't know. Yeah, I am somewhat far removed from that. I think many are not paying attention to this, or maybe don't care about it as much, but at some point it's going to become a problem. We're going to be seeing it at a kind of the manufacturer level. They're not going to be selling the equipment that uses these other refrigerants. When CARB put into place their requirements a few years ago, commercial refrigeration equipment manufacturers immediately said, hey, as of this cutoff date, we will not be selling this particular piece of equipment or this design or this system that uses this non-compliant refrigerant in your state anymore. So I think we'll just see that come across the board for the overall country, and it won't necessarily be, hey, you can't use this anymore. You're just not going to be able to buy the equipment or that design, or design your equipment for that refrigerant any further. But as far as government shutdowns, I know it was a huge news piece. It went on for quite some time. Um, I think we're all still here, standing. The country's still here, working strong, building America. We're still going. So it's just to me, it's just a blip in life, you know.
Yeah, I mean, the only effect I saw it. I mean, yeah, everybody lit their hair on fire over it, and when it really, I didn't see a huge effect. But the only effect I saw, as far as EPA, is we had some clients that had EPA inspections scheduled, and then government shutdowns happened, and then they're waiting for the EPA to show up, and they just didn't. And And right after government back up and running, they got emails saying, hey, we're rescheduling this to this date. So I don't know. I don't know. I was surprised by the quick turnaround, but yeah, no, I agree with you. I think it was kind of just a blip on the map, but not really going to see much else come from that.
Yeah, and on, kind of further down that same rabbit hole, I've been asked, do you think with the current administration, are we going to keep the AIM Act? Are we going to see these GWP restrictions be lifted? Are they going to stay? What's going to happen there? And I think it's administration or not, I think it's going to stay there. We've seen this is a global change that we're seeing. I think in Europe and or the world as a whole, we liked using ammonia a lot back in the day, and then Europe's kind of said, and this is my own, you know, synopsis of history. It's not even, this is my opinion really, but we saw Europe say, hey, we don't like ammonia. It's dangerous. It's a life safety hazard for sure. So they went to using synthetic refrigerants, and we worked through all of these as far as, hey, we have chlorinated refrigerants that are going to deplete the ozone. We've got HFCs that have a high GWP potential, and they said, oh, we need to lower that. So we went to the new HFO generation of refrigerants using HFOs that have very low GWP potential, but they're carcinogenic. They have PFAS or PFAs, however you want to say that are a known issue. Now we see Europe pushing with their F-gas regulation to get rid of those and go back to natural refrigerants, whether that's ammonia, CO2, propane, and so on. And I think as a overall world, I think we're going to see more push to that. I don't think we'll ever get rid of synthetic refrigerants. I think there's too much money in them. I think they are very well suited, and some of them are very, very well engineered for the other big headline in the news as far as AI and data centers. We talk about ammonia being, oh, it's the best refrigerant or one of the best refrigerants. I think that's the incorrect moniker for it. I think ammonia is one of the most versatile refrigerants. But if you take ammonia and pair it against, you know, I think it's 1, 2, 3, 4 ZE or YF, and put that synthetic refrigerant in a centrifugal chiller for a data center versus an ammonia system doing the same chilling work, that synthetic refrigerant is going to operate way more efficiently, or just as well, if not more efficiently, than the ammonia system, without all of the regulation involved with the ammonia system.
Ryan, I am so glad you just said that because I have been wondering, like, why in the heck are people not using ammonia for the data centers? I'm sure the load is crazy, and so I was like, and the energy cost is the big thing. And so I was like, why are we not using ammonia? So can you break that down a little bit further? You kind of mentioned like R134, I think you said. What's the
Yeah, there's so many of them I don't even keep track of them necessarily, but the there's a lot of newer low pressure refrigerants out there. Some like R1234 YF or ZE. If you have a relatively newer car, pop the hood, look what the tag says on the refrigerant. There's a chance, my Chevy Colorado that I have has a R1234 YF, I think, in it, refrigerant. But they work great in this super narrow operating window that either air conditioning or data centers operate at. Data centers, they don't necessarily need to cool the equipment, but they don't need to make it super cold. They need to just do sensible cooling. They don't even want to pull moisture out of the space necessarily. So, because that leads to potential static electricity. So, um, they're going to be operating at a suction temperature maybe around 50 degrees or so, 40 or 50 degrees. And that refrigerant, you know, compressing from that relatively high suction pressure or temperature to whatever the discharge pressure is going to be, which is a very narrow band of pressure ratio. That refrigerant works very efficiently there. The compressors, the centrifugal chillers can operate very efficiently. Even from a, you know, industrial standpoint, if we consider using a centrifugal chiller, some of the performance numbers are very impressive. We can have a ammonia system, like for a winery. A lot of times we'll run at a 20-degree suction, 90-degree discharge, especially on the West Coast, and that's kind of my standard operating condition for that application. So a recip compressor, which at those conditions is probably the most efficient compressor for an ammonia system, roughly speaking. Um, it's going to operate about 1 brake horsepower per ton, or 0.75 uh, kilowatts per ton at that condition. Similar centrifugal chiller can operate at that same efficiency number, potentially better. Now they're going to use a cooling tower, so there's pumps and there's more horsepower, other horsepowers involved that adds to that number. But that comparison goes even more in favor of the centrifugal chiller and the synthetic refrigerant as we raise the temperature up to that 40-degree, 50-degree suction temperature they're going to be utilizing at a data center.
That is, yeah, that's real interesting. It's good to have some insight from a true engineer on the design side that kind of can see the value there. I have ammonia on the back of my jersey, and so I'm always like, yeah, go ammonia. So it's good to get some truth on some of those other good refrigerants out there.
Yeah, and I've done a brief look at it, and a very brief look at it, and you can make them to be the ammonia system to match the performance of that synthetic refrigerant. But when you get to that point, you're not going to be low charge. And now you're going to have this huge industrial, data center that you've got to cool with an ammonia system that is at least going to have some PSM aspect to it, and more potentially has a RNP aspect to it. Whereas the synthetic refrigerant falls under ASHRAE 15, and for the most part, they don't have to worry about it. So why would that corporation, that business, choose ammonia and its compliance concerns over this other refrigerant that is equally or maybe more efficient at these conditions and doesn't have the reporting and the regulation along with it?
Well, Ryan, it's been great talking to you. The last time we talked, I want to say your wife was pregnant, and so how old is the little one now? I know it's been a minute.
Yeah, he's officially, I think, 17 months as of last week. Yeah, so he's going to be a year and a half here pretty soon. He's cool. He's a cute boy. He just runs around and does his thing, from about 6:30 a.m. to 7:30 at night. You guys know, you guys know how it is.
Of lock everything down in the house and make sure you can't get into the chemicals and yeah.
Yeah, but he's, starting to say please and thank you, and he can walk out with me to the truck and do stuff. So he's a ball of fun for sure.
Well, Ryan, if you can leave us with one thing that you see kind of coming for the industry at large of industrial refrigeration, what's something you kind of see coming that you'd love people to kind of stay aware of?
Um, you know, I see there's a lot of small stuff going on right now for sure. I think we see it or seeing a pushback towards DX designs with better controls, of course. I think more recently we've seen some big reorganizations of the contractor world, with smaller contracting companies getting bought up. But there hasn't been, I think, in my opinion, a huge change or huge steps in the industry made towards some new technology or some new idea that's going to change the world for us. Um, some things that I think we're definitely going to see is very soon, beyond ammonia, transcritical CO2 systems. In my opinion, still the wild west for the most part. We've got people doing whatever they want, and IAR has come out with their CO2 standard now, which is out there, and I don't think a lot of people are paying attention to that. But um, your local municipalities, your states, your cities, that whether they adopt IMC or UMC or CMC mechanical codes, once they adopt the 2026 or roughly that year, whenever they publish the newest edition, those codes are going to reference IIAR CO2. Yes, and we're going to fall under that regulation. So we're going to start seeing, much more regulation in the CO2 industry, for our refrigeration industry as a whole. So I think that's something to watch out for there. And something I would like to see our industry go towards, which I think helps you guys and your line of business quite a bit, is I would personally like to see more adoption of, you know, RMP, PSM and RMP, or CalArt Program 3, if you will, for nearly any ammonia system of any size. You know, for California, when we get below 10,000 pounds, it could be 9,900 pounds, a little questionable, but it still falls underneath that 10,000 pound threshold. Same thing for the rest of the state or the nation. Why do we not have to do the PHA? Why do we not have to have all these other items of compliance and safety? I think we should start considering adopting all of these, having P&IDs and SOPs, emergency response or action plans, doing PHAs, or even PHRs, process hazard reviews, which are still something that is required by IAR 5 or recommended at a very minimum. Let's start doing all of these, and maybe we don't have to report all of it like you do with a full RMP program, but let's have all of that on file so that way, as we go around, operators, technicians, safety managers, maintenance managers, whoever, contractors, go around, we have a somewhat unified set of documents that every ammonia system is going to have, even whether it's low charge or huge charge. So that way, everything's documented, it's covered. We've thought about it, done our due diligence to make sure that the system's safe and that we can operate it in a safe fashion. It's really an expansion of the general duty clause. Let's just make it congruent across the board. That's something I would love to see our industry go towards.
Well, well, Ryan, I'm gonna go ahead and Venmo you the $20 I owe you now for that plug to our to our industry. But I agree. I mean, wholeheartedly. Like the difference between a 10,000 pound system and a 9,500 pound system isn't that different. And I had a client that was actually, maybe I shouldn't say too much about it, but there was a fatality from an ammonia release, and it was just under the limit of 10,000 pounds. And now they were covered by CalArt Program Level 2, so they were doing the things they were supposed to be doing, and it was kind of a freak accident. But that being said, I mean, a 9,000 pound ammonia system can cause a lot of damage, and so to not be doing anything is a real poor idea. And frankly, I will say I've been pretty pleased with the amount of customers we have who have less than 10,000 pounds, but they're still taking it seriously. They still want P&IDs. They're still trying to do basically the general duty clause program, and I think that's the right way to do it. And that's the enforcement is different, right? Because they're not on the lottery system to come get an inspection. But what I tell people, and it's the truth, is that if you have an incident where someone does get hurt, they're going to come out and basically have expected that you were doing PSM. And so you're just kind of playing this game of hopefully nothing bad happens if you don't have a program, which I mean, you just shouldn't be doing in terms of playing with people's lives and the environment. So
No, totally, and clearly, end users are taking that next step, that initiative to do some of these things, whether or not they are required to or not. Especially if they're not required to. Hey, let's do a PHA or a PHR. Let's have P&IDs. Let's have SOPs, things like that. Let's just make it a standard. We're already starting to talk about it. Let's just do it. Let's make that a thing. I would absolutely love to see that. That way, it's just the technician goes somewhere. Hey, where's your P&IDs? Or hey, let's say a facility's gonna add as a 1,000 pound system, and they're gonna add another piece of equipment and expand the system that's gonna make it have 2,000 pounds of ammonia now. Super well below the 10,000 pound threshold, but you're doubling your offsite consequence potential. You're doubling the size of the system, really. And we're not going to do a PHA. We're not going to review, the design. We're not going to review the facility siting. We're not going to potentially be concerned about how you interact with this system and what might happen. Is the design thought of well enough? Are there valves that are going to potentially trap ammonia, or is there something else in the overall facility process that's going to create an upset and lead to a release that you're not considering, or a condition that you're not considering? Let's just talk about it and call it good.
Well, Ryan, thanks so much for coming on the podcast. It's been fantastic to have you. I definitely know I'm going to want to invite you back on again. But I'd like to kind of plug you. I think there's a lot of people who would appreciate your services. So if someone's looking to reach out to you for engineering, where should they reach out to you? And again, just kind of what do you offer at R2 Mechanical?
Yeah, no, totally. Thanks, guys. I appreciate it. And like I said before, absolute honor. Definitely exciting to be on the podcast. I listen to a few podcasts and it's like, oh man, it'd be great to be on one of these days. So pretty dang cool. Get to be that guy. Yeah, thank you. Maybe one of these days I'll get on, Jocko podcast or something like that. Something moving up in the world. Yeah, Joe Rogan.
There you go. Yeah, that's the order. It's Cold Truth and then Jocko. Yeah, so.
Well, Eli can put in a word with the big man. He met him once.
I did meet Jocko Willing one time. Yeah.
You did. I was a little jealous of that, but no. If anyone wants to reach out to me, our website is www.r2mc.net. We have a little contact us page on there. You can fill out a form. I pay attention to it very much. If you submit that form, it comes right to me. I'll give you a call or an email, whatever it is. We'll get in touch. And also connect with us on LinkedIn, either myself directly or R2 Mechanical Consultants has their own business page. And I haven't done it very recently, but every now and then I do post some technical articles up there. And you could always go back and look at them. There's some interesting ones on pipe pressure ratings or pull down for freezers and things like that. Some general stuff. We did one on energy balances after talking with you, Eli, I think 2 years ago or so. So yeah, just
about valves that I still have like bookmarked as a reference. So
good deal. Thank you. Yeah, no, I really appreciate it, guys.
Well, this has been the Cold Truth Podcast. Thank you so much for listening. Ryan Reardon, go check him out on LinkedIn and on his website. And Eli, we'll catch you in the next one.